let's say we have to find the extrema, so we're going to find extrema, so local maxes, or maxes and mins, we're going to say the interval is 0 to 6, okay? Closed interval, of course, of, and then here's our function, f of x is equal to x to the third minus 9x squared plus 24x, and then minus a 10, okay? So what's our first step? It's to find our critical points, okay? So critical points have to do with where f prime of x is either 0 or does not exist. So first of all, let's find our x prime of x, or f prime of x, excuse me. So that's going to be a 3x squared minus 18x and plus a 24. So if we take out a 3, factor out that 3, we get x squared minus 6x and then plus an 8. Okay, so we can actually factor that a little bit more. So f prime of x is equal to 3 times x minus 2 and an x minus 4. Okay, so here we see that this function is always defined. This f prime of x function is always defined. There's nothing like where we could have a fraction where there's a 0 on the bottom. So it's always going to exist. So we do have to find where it equals 0. So I made it pretty simple here. This f prime of x equals 0 when our x is equal to 2 or 4. Okay? So these are our critical points. So these here, I'm going to label those as CPs, our critical points. Okay? And now we can't forget about our endpoints, right? And so our critical points are 2 and 4. So x equals 2, 4. These are our critical points. And our endpoints, x equals 0 and 6. These are our end points. Okay, so we've identified those, and now what we want to do is plug in all of these values into our original f of x function, and I'll do that on the next slide. Okay, so now we have our x equals 2, 4, and 0, and 6. We can just group them all together because we don't have to identify them later on as critical points or endpoints or whatever. You just say this is the minimum, this is the maximum, okay? So we're going to group all those together, and our f of x, just a reminder, that was equal to x to the third minus 9x squared, and then plus a 24x minus 10, okay? So now, if we're going to try all of these points, we just plug them in, right? So f of 2, for example, that's just going to be a 2 to the third minus 9 times 2 squared plus 24 times 2 minus 10. And this is going to turn out to be 2 to the third is an 8. And then we have minus a 36, and then plus 48 minus 10. So this turns out to be a positive 10. Okay? So then we have f of, let's try 4. So then we have 4 to the third minus 9 times 4 squared plus 24 times 4 minus 10. And this turns out to be a 64 and then minus 144 plus a 96 minus 10, so that equals a 6 overall, okay? And then we have f of 0, of course. That's just going to equal everything that you plug in here is a 0, so minus 9 times 0 squared plus 24 times 0 minus 10, so that's going to turn out to be a negative 10, okay? And lastly, we have our f of 6, so that's going to be 6 cubed minus 9 times 6 squared plus 24 times 6 minus 10, so this is going to be a 216, and then minus 324, plus a 144, minus 10, so that's going to equal 26. Okay, so let's compare all of these values. So we have this one here, that's our f of 2. This one here, we're going to pull that out as f of 4. This one is f of 0, and this one is our f of 6. So I'll write these on the next slide, and we'll summarize what just happened. So, okay, so our conclusions are f of 2 is equal to a positive 10, f of 4 is equal to a positive 6, okay? F of 0 was equal to negative 10, and f of 6, when we plug that in, that was equal to a positive 26, okay? So these ones, just a reminder, you don't have to write this, but these ones were critical points, right? The 2 and the 4 were critical points, and these ones were our end points, okay? That's just to identify. And so now the third step is to compare the values that we have obtained. So the lowest value we see is this one here, this negative 10, right? So this has to be our minimum. So minimum. Okay, so our minimum is at 0, 10. All right, so you could write 0, negative 10. And then our maximum value we see is this positive 26, so we'll write maximum by it. And this point is actually 6, 26. Okay, so that's basically it. These other two values, they tried, but they actually didn't prevail in the end. They weren't minimum or maximum. Okay. All right, so that's it for that problem. And now we'll go on to one last topic. Okay, and this is the topic of it's actually a theorem, and it's called Rolle's theorem. Rolle's theorem. All right, and it's built out of what we've been learning about minimums and maximums, but it's a little bit different. So what we're going to say is that if, so this is how it starts because we always have to set up a theorem. So if f of x takes on the same value, so the same value at two different points on AB, so on some interval AB, points, just kidding, so two different points, A and B. Okay, so these points are x values, so x equals A and x equals B. Somewhere in between, we can conclude that somewhere in between the tangent line, so the slope of the tangent line, is 0. Okay, so that's basically it. That's all Rolle's theorem says. And pictorially, this is what it looks like. So graphically, we're gonna show this. So let's say A and B are here, and they happen to the function happens to take on the same exact value, the same height, right? So here's f of A, let's say, and this is f of B, which is the same thing as f of B. Okay, so in between here, somewhere, anywhere in between, the tangent line must have a slope of 0. Okay, and this is why, because so I'll write that out real quick. So tangent line is horizontal. Okay, because on a closed interval, we know that due to the extreme value theorem. So remember, I'm just gonna write due to the extreme value theorem, because we are given that f of x is, we're assuming it's continuous, okay? And then we know that the endpoints are included because we have this A and B there. So the extreme value theorem says that there must be a maximum and a minimum, okay? So at those maximum or minimum, then we either have to be at a critical point inside the interval at which the f prime of x is equal to 0. So let's say our critical point, like C or something, that's right here, okay? So it has to be inside the interval. There's our critical point. There has to be a maximum. So then at that point, we have our horizontal tangent line, right? Or at the endpoints, or our critical points, or not critical points, sorry, or our maximum or minimum have to be at the endpoints, right? So it's either at a critical point on the inside, at which the tangent line would be horizontal anyway, so we could have a minimum here, and when our horizontal tangent line pops up. So it's either on the inside or it's at the endpoint. So if we have, let's say, a maximum at A and a minimum at B or something like that, right? But we can't have that because that's an inaccurate drawing, because Rolle's theorem, our setup, remember, it was that A and B are at even heights, right? So if A or B, or I guess and B, if they're the maximum and minimum, that means we're at a constant graph, right? Because then that's both the maximum and the minimum on the interval, which is kind of weird. But anyways, then obviously our f prime of x is going to be 0. It's just going to be the line itself, okay? So anyways, we'll do a couple of practice problems. We'll at least do one example of the Rolle's theorem in the practice problems video, so you don't have to worry about that at all, okay? So basically, just a quick overview of Rolle's theorem. I'll just write that down. That's basically just saying that if you have those 2 points, if you have 2 endpoints to your interval and they happen to give you the same function value, then you either have to have the critical point on the inside, critical points on the inside at which the local max or min or whatever, that at that point then we have f prime of x is equal to 0. Or again, if we have that same setup, A and B, when you plug those in, you get the same height or the same value for your function, then it would just be a constant graph, and therefore the derivative is 0 at all of those points, right? So anyways, that's pretty much it. That's all about Rolle's theorem and about extreme values. So I hope that helps, and good luck on your homework. Heart attack.